3. Today we are going to discuss equilibrium of three forces. Equilibrium. Equilibrium means a body is said to be in equilibrium if vector sum of all forces is 0. If vector sum of all forces are 0, then it is said to be in equilibrium. If three forces are in equilibrium, here we are considering the case of three forces. If three forces are in equilibrium, we have two rules or two laws of equilibrium of three forces. The first one is law of triangle of force. It states that if three forces acting at a point are represented by the three sides of the triangle taken in order, then they are in equilibrium. For example, the force P is represented by the side AB of the triangle. The force Q acting at a point is represented by the BC of the triangle, and force R represented by C of the triangle. Now these three forces are taken in order. These are the three sides. Order, this is the order, this is the order. Order means cyclic order. They are taken like this. Then according to this law, these forces are in equilibrium. So we have drawn this diagram, okay, by taking the force P proportional to AB, the length AB, force Q proportional to length BC, force R proportional to length CA. So therefore, according to this rule, P by AB is equal to Q by BC is equal to R by CA. The converse of this theorem is also true. If three forces acting at a point are in equilibrium, for example, this is force P, this is Q, and this is R. If these three are in equilibrium, we can write them in the form of a triangle. Therefore, converse of the theorem is if three forces acting at a point are in equilibrium, then they can be represented by the three sides of the triangle taken in order. How to write it? Draw a line parallel to R, a line parallel to P, and a line parallel to Q. So these three are taken in order and they form a triangle. So this is inverse law of triangle of force. The law of triangle of force or inverse law of triangle of force gives that the P by AB is equal to Q by BC is equal to R by C. So there is one more theorem called Lamy's theorem. It states that if three forces acting at a point are in equilibrium, say again P, Q and R are three forces acting at a point, and these three forces are in equilibrium, then this law states that each force is proportional to sine of the angle between the other two. See, the angle opposite to P is alpha, angle opposite to Q is beta, and angle opposite to R is gamma. Then this rule states that, this theorem states that P proportional to sine alpha. See, the P, the force is proportional to sine of the angle between the other two alpha. Q proportional to sine beta. Is it clear? See, Q is proportional to sine of the angle between the other two. R proportional, in the same manner, R proportional to sine gamma. So therefore, P by sine alpha, this gives, is equal to Q by sine beta and is equal to R by sine gamma. We can use these two theorems, law of triangle of force and Lamis theorem, to find the resultant of three concurrent forces. Now, resolution of a vector. Resolution means splitting. Splitting of a vector into two or more vectors is called a resolution. Usually, if there is a vector P, if it makes an angle theta with x-axis, so these are the x and y axis, P is the vector P makes an angle theta here. The effect of vector P along x-axis is called x component. This is called x component, Px you can say. The effect of vector P along y component is Py. See, we have divided this P into two vectors, Px and Py. Okay? So in triangle, say OAB, what is Px? Px is adjacent side. Therefore, we can say Px equals P cos theta. Because cos theta is equal to Px by P from the diagram. Cos theta is Px by P. What about sin theta? This is also Py. If this is Py, this is also Py. AB is Py. Therefore, in the same manner, Py is equal to P sin theta. Because sin theta is equal to Py by P. So that means we have divided this vector P into two vectors, P cos theta and P sin theta. So this is called resolution of two vectors. We use these vectors in number of application. This is called resolution along Cartesian coordinate system. So we can divide this into number of vectors also.